This is an extremely important project. We'll be impacting 500,000 people in their lives daily every time they touch a faucet.
A raw water intake is a pipeline that goes out into Lake Michigan and pulls in just plain old Lake Michigan water for the Evanston water treatment plant to treat to drinking water quality standards.
The old intake was undersized to meet current needs and projected needs, and also underperforming. Built in 1909, well past its useful life. We weren't quite getting the flow out of it that we wanted to.
The intake we're replacing is over 100 years old, and we want the intake that we're installing to last for 100 years. So we have to innovate so it can survive the harsh conditions of Lake Michigan in the middle of winter.
We started with preliminary design, the planning phase, all the way through final design.
Specifically designing pipes and hydraulic systems and understanding how water moves through our environment.
Computational fluid dynamics, or CFD modeling, became very useful in the design of the intake structure itself. We wanted to make sure the speed at which the flow is coming into the intake structure is low enough that we're not pulling sediment into the intake structure and into the water treatment plant, which could be detrimental to the treatment process. Still working with the city through the construction phase, acting as the owner's representative out on site, overseeing construction activities.
Underwater work's difficult. Depending on the conditions, it can be very hard to see. Depending on how deep we are, there's not necessarily a lot of light. For the installation of the pipe itself, it's called a hydropole method. It's sticks of pipe in like 20 or 40 foot segments. And then we have to join them together, sink them to the bottom of the lake into the trench, join them to the other existing system. It's kind of creates a vacuum in a sense to like pull the pipes together.
Frazil ice has been an issue for intakes along the Great Lakes. In the winter, when conditions are just right, the water could freeze as it approaches and accumulates through the intake as it gets into the water plant. And that could cause a full blockage in worst cases. By adding a little bit of heat at the intakes, we hope to knock the system off that equilibrium to break up the ice so that we maintain water flow through the intakes.
To mitigate frazil ice formation, installation of heating collars and heating elements within the cone. The heating collars and cones are connected via cable back to power control centers, which are located in a valve vault back on shore. If the water is colder, we can increase the power output to those collars, which increases the heat output. Or if it's a little bit warmer water, we can decrease that power and conserve energy a little bit where we don't need it. Another problem we face here in Lake Michigan are the quagga mussels. These are an invasive species of mussels that have come into the lake via carrier ships that come into Lake Michigan.
Really build up on the intake, on both the intake and into the pipeline, and could reduce the capacity of the intake. They like the water flow, and the water flow gets food into them so that they eat. So they're really looking for food supply.
To disturb the chain of events or the buildup of mussel formation on the intake structure itself, the approach we took here was to pump out a chlorine solution out to the intake, where it's then distributed around the intake before then being pulled back into the plant itself. By doing this, we create a hostile environment, and it keeps them from growing on the intake structure itself as well as the piping.
There were multiple engineering disciplines as part of the project. We had civil engineers, structural engineers, electrical engineers. Collaboration at Santec's is really important because we were able to get people that are specialized and know what they're doing and make a better product overall.
This is a legacy project, so there's a lot of pride behind it, behind the team that we've got here working on it.
I grew up right near Lake Michigan. I think anyone who is from the Great Lakes region loves the Great Lakes. It's such an important part of our community. I know people that are going to be drinking this water, and it's really cool to work on projects knowing that you're benefiting the community at the end of the day.